This is apparently number 39, solving equations with rational exponents. How do you solve equations with rational exponents? And scholars will solve equations that have rational exponents, keeping in mind that rational exponents are exponents that are fractions. So there's no information here to give as far as you need to write this down. We're just going to start immediately with examples. So our first example says x to the 1/3 is equal to 4. So I'm going to do x to the 1/3, save a little space, is equal to 4. So, of course, with any equation, my goal is to get x by itself. So in order to do that, I'm going to raise both sides to the third power. Because remember, whatever I do to one side, I have to do to the other. So on the right side, that side is easy. 4 to the third, that's 64. On the left side, we have x to the 1/3 to the third. Remember, this is power to a power, and power to a power means that you're going to multiply. 1/3 times 3 equals 1. So then we are left with x is equal to 64. On the next one, we have 7 is equal to r to the 1/2. So again, we are trying to remove that fractional exponent. So in this particular case, we are going to raise both sides to the second power. So 7 squared is 49. And then r to the 1/2 squared. Remember, power to a power means that we multiply. So half of 2 is 1. So then on the right side, we have just r. And then lastly, when I look at a problem like this, it is going to be completed the exact same way that you would do any other equation when you're trying to get x by itself. Okay, so the first thing you're going to do is divide both sides by 4. So x to the 1/5 would be equal to 2. Now we got to get rid of that fraction, so I'm going to take both sides to the 5th power. So x to the 1/5 to the 5th, remember that is power to a power that you're going to multiply. So you end up with x, and then 2 to the 5th is 32. And that's it. Let's get a little bit more difficult. So in the next examples, now we have rational exponents that have something other than 1 in the numerator. So I have x to the 3/2 is equal to 27. So I'm going to take both sides and raise them this time now to the 2/3 power. And I'm doing it to the 2/3 power because I need to be able to cancel out that 3/2 in order to get 1. So I need something to multiply by to get 1. And so now here in the numerator, I have 3 times 2. And then in the denominator, I have 2 times 3, which will give me 6/6, which is 1. So on the left side, then, I have x. And then on the right side, I have 27 to the 2/3. Well, these are the type of problems that we talked about in class previously. So I'm going to take that 27 and rewrite it as 3 to the 3rd. So 3 to the 3rd to the 2/3. And when I do that, these two will simplify to 1. So then really what I'm left with is x to the 3rd. I'm sorry, x is equal to 3 squared. And so then x is 9. And the same thing with the other one down here on the bottom. I have m to the 3/4 is equal to 27. So I'm going to raise both sides to the 4/3. So again, this is 1 and this is 1. So on the left side, I have m. And 27, I can rewrite as 3 to the 3rd to the 4/3. These will cancel to give me 1. So then I have m is equal to 3 to the 4th. And so that means that m, I accidentally tapped the eraser. So that means that m is equal to 81. So even though we don't have 1 in the numerator, we still have the tools and skills already that we need in order to figure out what we need to do. Okay. So then in example number 3, it's going to get a little bit more difficult, and then we're going to stop at example 3. So here's example 3. So they look a little bit more difficult, but I promise you guys they are not. And these problems do take a little bit more room. So what I'm going to do is I am going to take this and make it a little bit smaller. Put it over here in the corner so I can use it as a reference. And then I can actually write out the problems. Let me get that little blue mark. It was bothering me. All right. So the first one I'm going to do is n minus 27 to the 3/2 is equal to 64. So I need to get rid of that exponent again. So I'm going to raise both sides. I'll pick a different color. Raise both sides to the 2/3 power. Okay. And so then on the left side, those are going to simplify to give me 1. So then I'll have n minus 27. And then on the right side, I'll have 64 to the 2/3. So then n minus 27, I can rewrite 64 as 4 to the 3rd. So that's 4 to the 3rd to the 2/3. And these 3's will become 1. So I have n minus 27 is equal to 4 squared. So n minus 27 is equal to 16. I'm going to add 27 on both sides. So n is equal to 43. On the next one, I have 26 is equal to -1 plus, in parentheses, 27x to the 3/4. Okay, so notice that the only thing that's in parentheses is the 27x. So the first thing I'm going to do is add the 1 to both sides. So 27 is equal to, that's 0, 27x to the 3/4. Okay. So now I need to remove the exponent. So I'm going to take both sides and I'm going to raise it to the 4/3 power. Okay. And so then on the left side, excuse me, I have 27 to the 4/3. And on the right side, I have, these have canceled and these have canceled to leave me with 1. I have 27x. So let's figure out what I need to do next. I'm going to divide by 27 on both sides, right? And so this one is kind of interesting because there's really 2 routes that I could have gone, and I'll show you the other one in a second. But I'm going to divide by 27. So when I divide by 27, really I have 2 bases in different exponents, right? And so the rule, when I have a quotient of exponents, I subtract the exponents. So I would do 4 over 3 minus, and the exponent here would be 1. So 4 over 3 minus 3 over 3 is going to give me 1/3. So then on the left side, I'm going to be left with 27 to the 1/3 power is equal to x. And 27 to the 1/3 power means I have 3 to the 3rd to the 1/3. And so that means that 3 is equal to x. So that's one way that I could have done it at that point. The second way that I could have done it at that point is if I had 27 to the 4/3 is equal to 27x, then I can figure out what 27 to the 4/3 is. It's going to be 3 to the 3rd to the 4/3, and then those will give me 1, so I have 3 to the 4th, and then 3 to the 4th is equal to 27x. Well, 3 to the 4th we know is 81, So 81 is equal to 27x. Divide both sides by 27 so that x is equal to 3. So either way it goes, two different approaches, both still the same, both still get you the same answer. Okay. And then for the last one, I'm kind of out of room. Let's see. Give me a second. I think I can take this one. I'm going to take this one, make it smaller, and move it over there so that it will still be on the screen. And let's make this last one blue. So I have x to the negative 3 over 2 is equal to 1 over 729. So the first thing I want to do automatically is make my exponent positive. So if it's in the numerator, I'm going to move it to the denominator. So now I have 1 over x to the 3 halves is equal to 1 over 729. Right, so since they're both in the denominator, then they both have 1 in the numerator, then I know that x to the 3 halves has to be equal to 729. Okay, so then I'm going to raise both of them to the 2/3 power. And on the left side, they're going to cancel, and I'm going to be left with x, and then x is equal to 729 to the 2/3 power. And so now we have to figure out what to the 3rd power is going to give us 729, and I believe it's 9 to the 3rd power. So I can rewrite this as 9 to the 3rd to the 2/3. Those will give me 1. So then I have x is equal to 9 squared. So x is equal to 81. And that is it. So not as difficult as we think it's going to be, because we already have the prerequisite skills of simplifying rationals to help us out. Now we have to put it all together with solving equations. That's it. Have a great one.